Alright, here I am with the promised video explaining how the hell this thingamajig works. And why now there are two Arduinos instead of just one. But yeah, first of all, why don't we just connect everything and we get it actually working, so I can give a quick rundown about it. First the Mega, then the fuck, I was plugging in the wrong spot, whoops, and then I'll just turn on the logic analyzer, and finally the Nano that's actually going to be sending the data. There we go. You can see all the LEDs are on. There's actually a little bit of data transfer here. But basically what happens is, when you press a button here, left, right, up, down, not to really remember which order it was in, it is going to receive here. It's the prototype microcontroller. And then the prototype microcontroller is going to transfer it to here. This is just here for to prototype the communication. Not really much more to it. Anyway, let me give a quick rundown of how it works.
One eternity later.
So you may actually have noticed that like it took a little bit of a while to get it actually work for me to, that's actually one of the problems with this particular implementation. I'm gonna discuss them later. But basically, if we go, I have over here Eclipse open. That's what I use to program. And basically, yeah, it's just this is the code pretty much. First part is basically just setting up all the pins. I'm doing this very low level to save space because I'm going to be using a very tiny microcontroller. I actually have it here beside me. Then what do we got? This is the measured time constant vector. This is the calibrated time constant vector, and this is what I'm going to talk about later because on this current circuit, where the parts are very mobile and nothing is really too fixed, there's kind of a little bit of a problem with the capacitances varying just because they feel like it. If there's like a tiny movement or something, or a wire changes position, it basically makes the capacitance change. And since we're looking at a very minute change in capacity, that can lead to problems in detection. So yeah, okay, we got that out of the way. So how about here's the actual program loop. We have this toggle interrupt because we don't want to be transmitting data while we are reading, or that could lead to very catastrophic situations. So this is gonna just block interrupts whenever it's doing a detection, a reading. Then what we got here? So this is gonna be this is the if else statement for cycling the ports. Not gonna go too much into detail on that, because the real money here is when we get to the threshold time. It's gonna be running in a cycle as long as it can, unless it is TRD is above 900. I think this was milliseconds. No, microseconds. Right. 900 microseconds. And it's basically just gonna write to this DT what is the current position of your finger. And now you just press here, ba, 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 ba. If you're attentive, you might have seen that there was a little bit of a change on the screen in the serial monitor view. If you're not, I'll show you. I'll make it more apparent later. This is the interrupt. This is the interrupt function. It's just was a pain in the ass to program, but it works because we really gotta work with the I2C timings. It's very rudimentary too, I'll give it that. Very bare bones. Could probably do with improving it. But I mean, this was basically just the proof of concept. This was basically just the proof of concept program for the prototype. I'm not going to be using the Arduino from here on forward, at least for this project. And so I will just have to adapt. I will just improve upon it on the next iteration of code. And the toggle interrupt is just, well, a toggle interrupt. I just toggle the interrupt control signal. Not much to it. It's an exclusive OR. So if it's 0, it becomes 1. If it's 1, it becomes 0. If you have a way to keep track of the current interrupt statement, you basically don't really need to worry about it being toggled wrong. But yeah, that's it for the code. On the other part, we have basically on the Mega, we just basically have a code to you're seeing it on the screen right now. It's very tiny. I'll probably zoom it in once I get to editing, but if I increase the window, the code doesn't increase. Yeah, but it's basically just waiting 900 microseconds, requesting a new byte from the tiny here, the nano. It's kind of weird saying nano since I immediately think of iPods. But yeah, basically that's it. And here is the plotter for what the Mega is receiving. If we go back up, we can see that right would be 1, top would be 2, left would be 4, and the bottom would be 8 since we're just flipping bits. It also has the compound effect of we can encode this using just numbers, and basically each key combination has a unique has its own unique number. And if you just bang your hand on the which I'm not gonna do because I already spent way too much time calibrating this right now. But yeah, it will detect as its own unique combination. And again, the middle doesn't work. Not in this version, at least. I'll talk about that later. But yeah, once you press... can I make this line? No, I can't change this line. God damn it. But yeah, when you press, let's start. Right. You see that there are a few spikes of 1. We can smooth that out. We can smooth that out once we get the actual driver for whatever we're gonna use. We can smooth that out and make it, well, less jaggedy. But yeah, same thing for the others. Also, calibration would play a big role here, but yeah, I did a very rough manual calibration just for sanity's sake. But yeah, that's pretty much it. If you want to see the I2C, it's sending data right now. I just did a run here, and basically it's 0, because it's empty. This is a logic analyzer. I'm running it at what, 8 megahertz. Signal I think is 400 kilohertz. Don't take me on that. I'd have to check the code again. But if, as you can see, the master is requesting the address and saying that it's read. The slave is acknowledging. The slave is sending the data. It's currently nothing was being pressed when this was read, so it's a 0. And there's this it is not acknowledged at the end, which I just think is a bit of a quirk of the wire, well, the wire library on the Arduino, because it always says neck, but if you go to the plotter, it's actually plotting, so it doesn't really seem to be much of a problem with the doesn't seem to be really a problem with the communication itself. It's probably just doing a non-acknowledgement to then be able to just immediately after send a stop signal. So I think that might be a quirk, might not be, I don't know, but it's there. I'm gonna have to look into it. And I mean, what can I do? Oh yeah, I didn't. It's actually out of frame, but here's a logic analyzer if anyone's wondering. Actually very tiny for what it does. But yeah, this is a prototype. It's done. It works. I've shown it to you. It's a pain in the ass to calibrate, and I'll get onto that. These components, well, this is a very, how can I say, volatile board. The wires are just all over the place. They shift, they change position. The capacitors too, sometimes they get dislodged. It's just a mess, but there's an alternative to that. This was currently under here, and I'll take this all away from here, turn it off, don't need it anymore. There you go. So currently I'm doing this testing. Ooh, get it out of here. Currently I'm doing the testing with this, right? It's pretty dumb. I managed to like, oh, embellish it a little bit, just so, oh god, gonna have to refocus it. All right, focus. Yeah, you know, put a little bit of graphics in it. But it's really just dumb. It's basically just the traces. Not much to it. Back is empty. Life's good. But and I fucking hate Droid Cam because it doesn't have autofocus. Well, doesn't have dynamic autofocus at least. But what's the next step in any prototyping? You go from this. Fuck. The mat is in the way. All right, and this arrived actually last week. It's if it can focus, it is version 2.0. Now with a finer wheel, the middle button, most importantly, well, simplified. Anyway, I/O, and most importantly, all the circuitry is on board. Very tiny things. Look at the size of this. Look at the size of this. It doesn't want to focus. Yeah, it really doesn't want to focus. I guess this is the best I'll get. Oh, god damn it. Yeah, but basically very tiny stuff. And most importantly, all the traces are fixed. All the capacitances are fixed. And we probably will, if my hunch is true, we probably won't have as many troubles with capacitances shifting and changing and just being a complete pain in the ass. And if there are actual problems with capacitances and such, it could be very simple to just do a self-calibration routine to run every, I don't know, 30 minutes, 1 minute. I would have to do some stress testing to see how long it can go without shifting. But so far so good. I also got a few things I would like to share on the mail. Actually, they're pretty cute actually, from how small they are. Yeah, this wasn't the one that I wanted to show, but look at the size of these chips. They're tiny. I mean, what can I get for comparison here? I mean, they're just tiny. This is 5 centimeters for reference. And this would be the one that would go over here, U2. Not gonna bother with focus this time. But yeah, it's tiny stuff. Will I be able to solder it? I don't know. The last one should be coming in sometime this week, the last piece. So we'll see about that. I'll try to make a soldering stream. I don't know. Tell me what you think. This is the microcontroller we're gonna be using. Also very tiny. It has what, 24 pins? 28 pins, actually. Still very tiny. Well, the other components are way too small. If I try to make it visible on camera, it won't focus. So I'm not even gonna bother. But yes, I am glad to say that this is finally going forward. Anyway, yes, I might try streaming the soldering itself. Is it a good idea? Is it a bad idea? Who knows? But I'm gonna try to do it anyway. So yeah, thank you guys a lot for sticking with me even at my absences. I've been unreasonably busy with a lot of things outside of streaming, of course. And I really hope I manage to get a steady schedule. Otherwise, you're just gonna have to. Otherwise, I'll just have to appear every now and again to mark presence. But yeah, thank you guys very much for watching. Not sure if I'm gonna do a giveaway. I'm not sure if giveaways are gonna keep being a thing, but yeah, I actually didn't have prepared anything from the last giveaway. I guess I'll just keep that in mind for the next time. Shit, I didn't actually select a winner for last week's giveaway. I guess I'll just have to make 2. But let's say that this week where I'm giving off this. If you want the chance to win whatever the hell this is, post a comment below. I will be selecting them next time, both for the CD 4051 and for the first touch wheel prototype, really. if you want to be a part of that, I will be giving it away. Of course, there's also always the caveat of be in Europe, be somewhere that I can actually ship without too much paperwork, and yeah, you may just get this. Thank you very much for watching. Leave a like below if you enjoyed this video. Subscribe for more things if you want to keep following me in my electronic shenanigans, and leave a comment below if you have any suggestions, questions, shit posts, criticism, anything really. I'm not gonna judge, and you can judge me all you want, so it's a win-win, innit? Yeah, thank you guys very much for watching, and I'll see you all next time.